This problem and all other data structure problems can be found here at Sarai Studies. Link is in the description box below. This is quick weighted union, so it's the same setup. If we have n is equal to 5, that means draw 5 circles. The rules of the game are start at 0 no matter what version of the game you're playing, and then continue. And same thing as quick union. Parents, the vertices directly connected to each vertice at the beginning are themselves. They are directly connected to themselves, and so therefore the parents of each vertice are themselves at the beginning. Then recall union PQ. These are P values. These are Q values. Remember the analogy that in quick union we wanted to connect the root of the people to the root of the queen. Basically make the root of the people child of the root of the queen, because who wouldn't want to be the queen's child? That was kind of the way that I remembered it. But now quick weighted union, it's not based on status. We're not going to make the root of the people a child of the root of the queen just because it's the queen. Now it's based on how much weight the root of the queen has, or the root of the people. Whichever one is smaller, that's the one we're going to connect to the other one. And you'll see what I'm talking about. So here's how we do it. Union 4, 0. Find root of 4. So the root of vertice 4 is itself. Find root of 0. The root of vertice 0 is itself. So because the size of the sets are the same right now, each set only has 1, then it doesn't matter what we do. So we default to quick union, which was to connect the root of the people, which is 4, to the root of the queen, which is 0. So we make the root of the people the child over the root of the queen. So in other words, take this and make it a child of 0. So this goes here, points to 0. So then I asked myself, okay, well, what happened here in terms of what the parent is? Well, now the parent of vertice 4 is no longer itself, but instead it's 0, because remember the parent is the vertice that directly connects to 4 in this case, and that is 0. So this changes from 4 to 0, and then everything else drops down. Then union 2, 3, find the root of the people. So the root of 2 is 2. Then find the root of the queen. The root of 3 is 3. Because the sizes are the same, make this the child of this one. So basically quick union, like so. Then I asked myself, well, what happened? Well, now the parent of vertice 2 is no longer 2. It is now 3. So that changes to 3, and everything else drops down. And finally, here's where the real difference comes in weighted union. Find the root of the people, that's 3. Find the root of the queen, that's 1. Because the size of this one is bigger and this one's smaller, we want to always connect the smaller to the bigger one. So then that means that 1 here becomes a child of 3. Or in other words, the root of the queen becomes a child of the root of the people. So status doesn't matter anymore. So this, instead of pointing to itself, will now point to here. And then you ask yourself, well, what changed? Now the parent of vertice 1 is no longer 1, it's 3. So this changes to 3, 0, 3, 3, 0. So this here is your final parent array. It tells you the parent of vertice 0 is 0. And you can see that the parent of vertice 0 is itself, it's 0. The parent of vertice 1, directly connected to that, is 3. So it is 3. The parent of vertice 2, what is it directly connected to? 3, so it is 3. Vertice 3 is connected to itself, so vertice 3's parent is 3. And then the parent of vertice 4, what is it directly connected to? 0. So that's all it means.